Good morning all. Today we are going to see about the maximum flow problem in design and analysis of algorithm. So maximum flow in the sense it is defined as the maximum amount of flow that the network would allow to flow from source to sink. Here the multiple algorithms exist in solving the maximum flow problem. So two major algorithms to solve these kinds of problems are Ford-Fulkerson algorithm and Dinich's algorithm. So maximum flow problem, let's have the given input as the directed graph, that is G, which is equal to vector comma edges, that is V comma E, and will be having the supply source node as O and the demand sink node as T. And then we'll have the capacity function E and R. The main goal is to the given R capabilities send as much flow as possible from supply node O to demand node T through the network. So Ford-Fulkerson algorithm, it is developed by L.R. Ford, J.R. and the D. Ford-Fulkerson in 1956. So the input requires are network graph G, source node S and sink node T. So this algorithm implies the Ford-Fulkerson graph of G, node S and node T, that is the source and the destination S and T. It initializes the flow in all edges to 0. So from zeros to all edges, how the data are calculated, while there exists an argument path P between S and T, that is source and sink, in reducible network graph. The argumented flow between the source and the destination along the path P, it updates the residual network graph and again it returns back. So this is the process. So let's see the sum, how it solves.
So this is maximum flow problem in unit 4. In theory part, it is uploaded in SNS courseware. You can make use of it. Now we can see only the problem of the maximum flow problem. So this is a sum we are here going to give, that is from S to T, that is the source to sink, how it is flowing. You have so much of paths over here, like S to C, D and T is one of the path, and second one is S, A, B and T is the second path, and third one is your S, A, C, D, T, and finally fourth one possible path is S, A, C, D, B and T. These are the four possible paths which you can able to flow the process. So the maximum flow problem is like for example, if you take it as an pipe, okay, so pipe la vandu water flow agum illaya, so how much it can take, like if 5 liters type adla possible abdina, we can able to send only the 5 liters. So that is the main process over here. Like for example, if you take it as SABT as a path from source to sink, if how many liters it can able to flow? Anyone can try it? So the how many liters it is able to pass? S to A is 10 and A to B is 5 and B to T is 7. This is the overall path which is flowing over here. In which is the maximum flow we can able to pass. So அதிகமா எவ்வளோ லிட்டர் ஆஃப் வாட்டர் நம்ம இதில் சென்ட் பண்ண முடியும்? Only 5 liter. Why? So the space of S to A we can able to send 10, whereas in space of A to B we can able to send only 5, and B to T we can able to send 7. So maximum flow of S to T we can able to send is 5. That is the thing which we are shown here. So the maximum flow of these things is 5. So the flow which is equal to flow plus 5. So the given graph which is changed as 5 by 10, 5 by 5 and the 5 by 7. So this is the changing of the path. And after that we are going to select the second path as S, C, D and T. So S, C, D and T is again we are going a path in which the minimum path is 8. So that we are choosing already chosen 5 plus 8. So total will be having 13 flows over here. So after passing this, we got 8 by 8, that is 0 over here, and 8 by 10, which is 2 over here, and 8 by 10, then again 2 over here. This is your second path. Now we are going to select the third path. So with that is S, A, C, D and T. So S, A, C, D and T, in which the overall path flow is 2. How come we can say S to A you have 5, A to C you have 2, C to D also you have the balance of 2, and D to T also the balance overflow is 2. So that the maximum flow is 2. So overall flow is already 13 plus 2, then the overall flow is 15. And afterwards the final graph is like this only. So what about the fourth path? The fourth path, it is not possible because the fourth path is also again S to A, then A to C. So S to A and A to C is already 0. So 0 flow is there. So the fourth path is not possible. So overall maximum flow problem, the maximum flow is 15. So in PPT uploaded in courseware, you have 2 more examples of graph. You can try it. If any doubt, please contact me. Thank you.